All right, let's just jump right in. Today we're diving deep into an explainer on something that is quite literally reshaping the digital ground right beneath our feet. We're talking about designing AI-native application frameworks in 2026. Now, if you're building software today, you already know the core challenge. We are way past the point of just strapping a fun little AI chatbot onto an existing product and calling it a day. Building a truly AI-centric SaaS product right now means you're dealing with unpredictable, non-deterministic outputs, you're handling really complex multi-model routing, and you're wrestling with an architecture that has to evolve faster than it ever has before. It is completely exhilarating, but yeah, it's also incredibly daunting.
Look, if you're feeling that anxiety, you are definitely not alone. The right way of doing AI changes every week. That's just the hard truth of the era we're in right now. Unlike traditional software that sort of evolved slowly, layer by layer, AI is evolving systemically. The models, the underlying infrastructure, the tooling, even user expectations, they are all accelerating all at once. And what that means is AI creates technical debt just as fast as it creates value. Literally, the moment you ship an AI system, it starts aging.
We're essentially facing a massive structural shift right now. The stability of those classic software as a service models, it's faltering. Traditional B2B customer acquisition costs are way up, net revenue retention is dropping, and classic SaaS valuations are definitely taking a hit. But meanwhile, AI adoption is just skyrocketing. We are at this massive, strategic turning point, and the old models are basically forcing you to adapt or die. Think about it this way. Traditional software is kind of like a train on tracks, right? It's highly predictable, it's heavily constrained, it's very linear. But an AI-native SaaS, that's more like a self-driving car navigating a really chaotic, real-world environment. You just can't bolt an AI engine onto legacy architecture anymore. The foundation itself fundamentally has to change.
So how do we actually go about building this thing? Well, we're going to solve this challenge systematically, layer by layer. We'll start with the debt crisis, then move into the 2026 AI native stack, cover core patterns, discuss multimodal routing, look at securing the system, and finally wrap up with designing for obsolescence.
All right, kicking things off with part 1, the AI technical debt crisis.
So there is a fundamental difference between a traditional app that just has AI kind of bolted onto the side and a truly AI-native product. With traditional SaaS, your compute cost per API call is, near zero? The outputs are highly predictable, and the AI is really just a cute feature sitting in the corner. But in an AI-native product, the AI actually is the core value proposition. Suddenly, you're dealing with non-deterministic outputs, meaning the exact same input can give you completely different results. You've got these highly variable per-request costs that you absolutely have to model into your pricing. Plus, you need continuous evaluation just to catch regressions. If you try to build AI-native products using a traditional architecture, you are going to hit cost, latency, and quality walls within months. For sure.
Moving right along to Section 2, the 2026 AI native stack.
Okay, let's look at the high-signal tech stack that's really dominating the landscape right now because this shows us exactly what forms a solid foundation today. For your front end, Next.js 15 is giving you those server components in the edge runtime that are just absolutely crucial for performance. Then for integration, the Vercel AI SDK 4X is a total game changer. It gives you this beautiful unified API across all your providers, which makes tool calling and, most importantly, streaming responses incredibly trivial. Because remember, time to first token matters way more to your users than the total generation time.
And for your database, the absolute smartest strategic move right now is combining PostgreSQL with the pgvector extension. By using just one single database for both your relational data and your vector embeddings, you save your developers the massive headache of provisioning and managing a totally separate, dedicated vector database right out of the gate. The prevailing wisdom right now is to just stick with pgvector until you cross that 1 million vector mark. Keep it simple early on.
Which brings us to Section 3, Core Patterns, RAG, and Agents.
Listen, every single modern AI native app out there is built on a combo of these 3 core patterns. First up, RAG, or Retrieval Augmented Generation. This is basically how you connect an LLM to user-specific private knowledge bases. Second, we have agents. These guys execute multi-step workflows totally autonomously. They plan, they use tools, they deliver results. And third, embeddings. These power the semantic search, the recommendations, and the duplicate detection running right beneath the surface. These 3 patterns, they are the absolute engine of your application.
Let's actually visualize how one of these agents operates out in the wild. Imagine a deep research agent tasked with finding a new drug target inside massive amounts of clinical trial data. It's a really long horizon task. First, it has to think, literally formalizing a pause just to understand the complexity of the request.
Then, it plans out its multi-hop retrieval strategy. Next, it executes by pulling the data and running the SQL queries. And finally, and honestly most importantly, it reflects. It assesses itself. Wait, is this data actually complete? Did I even answer the prompt? And if not, it adjusts its plan and loops right back around. This explicit think, act, reflect loop is exactly what elevates an AI from a basic chatbot to a truly autonomous worker.
All right, let's shift gears to the economics in Section 4, Multi-Model Routing Strategies.
Okay, let's dive into this, because if you're relying on one single massive model to handle every single request in your app, it is going to absolutely destroy your margins. Seriously, just look at this difference, $2.50 versus 15 cents. That is the cost difference per 1 million input tokens between a complex frontier model like GPT 5.5 and a much simpler, faster model like GPT-4o Mini. If you're using the heavy model to just, format a date or classify a really simple user intent, you are literally burning cash for absolutely no reason.
So how you design your routing logic is crucial. You want to use a cheap, incredibly fast classifier model right on the front line to direct traffic. Generally, about 60% of your requests, the simple extraction or formatting stuff, goes straight to that 15-cent model. Medium lift tasks, like summarization, they go to a fast, middle-tier model, something like Claude Haiku 3.5. You really only want to reserve your heavy hitters, your GPT-5.5s or Claude Sonnet 4s, for the 10% of tasks that actually require deep, complex, multi-step reasoning. This routing architecture is how you preserve that snappy low latency while fiercely protecting your gross margins.
Next up, Section 5, Securing the AI System.
Now, when you start giving AI systems autonomy, you suddenly need some pretty terrifying new security protocols. These are the critical vulnerabilities that are actively keeping security teams up at night. You've got prompt injection, where attackers actively trick the system prompt. You have PII, or personally identifiable information, getting exposed right in your observability logs. But honestly, the scariest one? Multi-tenant RAG data leakage. Imagine you're running a shared database. A single missing where clause in your vector retrieval pipeline could literally expose one enterprise customer's highly private financial data to a completely different customer through a conversational AI response. I mean, that is a company-ending event right there.
Which brings us to this absolute golden rule. I seriously want you to burn this into your engineering culture. The LLM is a suggestion engine, not an authorization layer. Never, ever trust an AI output to make a final authorization decision. If your agent is supposed to send an email, modify a database record, or trigger an API call, you absolutely must validate those permissions service-side using hard-coded logic before the execution actually happens. Remember, the AI suggests, your system authorizes.
And finally, we arrive at Section 6, Designing for Obsolescence.
If you want to actually survive this era, you literally cannot get attached to your code. Because the ecosystem is systemic and moving so incredibly fast, you have to treat every single AI feature you build today as temporary. You've got to abstract your provider interfaces. Please do not hard code a dependency on just OpenAI or just Anthropic. You need to be continuously benchmarking models against each other. And you absolutely have to automate your evaluation systems so that when a model silently updates overnight, you know immediately if your product quality just dropped.
It all really boils down to this one punchy, bold philosophy: design for replaceability. Your models, your vector stores, your orchestrators, every single one of them should be swappable with minimal code rewrites. Honestly, if your application can't swap out its entire AI brain for a newer, smarter, or cheaper one in a single afternoon, your architecture is already dead in the water.
So I'm going to leave you with this provocative question, something to really chew on and take back to your teams. Are you prioritizing stability or learning velocity? Because in this era of AI-native SaaS, the companies that end up winning won't be the ones who minimize change or try to build the most rock-solid, stable monolith. No way. The winners are going to be the ones who completely maximize their adaptation speed. The landscape is shifting every single week. You need to make sure your architecture is built to shift right along with it. Thanks so much for joining me on this explainer, and I will catch you on the next one.